Good morning or good afternoon, as the case may be. My name is Sosale Mohana. I'm a maths teacher who has taught maths for over 50 years in 3 continents and 3 countries, like India, in Asia, Kenya in Africa, and England in Europe. I've just retired a couple of years ago, and I thought I should use my experience to record and deliver a number of lessons based on the British curriculum for A-level maths, so the students who want to reinforce their learning can use it. I have a master's in maths, of course, way back in 1969. I completed my master's in maths, and then I did my teacher training in 1974. I've been working since 1969 till 2019, clear 50 years. So I hope these lessons are useful to you, and you're welcome to watch them, and then with each lesson, there will always be a document which covers whatever has been done in the lesson, so you could use that perhaps as your own notes, or maybe to go over what has been taught during the lesson. I hope you enjoy the lesson.
Hello, welcome back. So we have talked about factor and remainder theorem in the last lesson, and of course I have given a number of examples, but I haven't talked about, I taught you long division, but there are shortcuts to long division, there are shortcuts to factorization. I will try and give examples for both, but as I said, it's up to you. You need not use the method which I'm teaching, but I find it at times useful. But there are some restrictions for these methods, which we will see in a minute. Let me take the example which I took last time so that it's easier to deal with. I think I took, I'm not too sure what example I use. It doesn't matter. Let me take any example. For example, you see, you had, so I'm now still in basic algebra. I'm still dealing with factor and remainder theorem. I'll just put it as remainder theorem. Remember, if the remainder is 0, it becomes a factor theorem. And then we did long division, and I need to talk to you about another way of doing long division, which is much quicker. For example, let's say find the remainder. I mean, how would I put it? Find the remainder when x cube minus 6x squared plus 5x. I'll have to work out f of x equal to minus 1 minus 4 minus 0 minus 1 plus 12 is divided by x plus 1, and hence factorize. I'm just taking a simple example, f of x. So what would you do? Obviously, remainder, so we use remainder theorem, x plus 1 equal to 0, x equal to minus 1. So what is f of minus 1? Is minus 1, minus 6, minus 5, plus 12 equal to 0. Therefore, x equal to minus 1 is a root, or x plus 1 is a factor. This you learned. Last time I told you how to solve a cubic or a 4-degree equation. You find one root by either it's given or you do trial and error, and then you divide. So what would you do? In the previous case, you did x cubed minus 6x squared plus 5x plus 12, and then you wrote x plus 1, and then you compared. You went on writing 2.5 pages. That division can be done in 1 line. Sorry, in 3 lines. But Word of caution, do not use this method if it is not a factor, and also if it has to be a linear factor. You can't use it directly for a factor like x squared minus 1 or x squared minus 4. You can only use it if it's a factor like x minus 1, x plus 2, x minus 3, x, so on. So what we do is this. Write an L. Good. Do not write the equation, write the coefficients. X cubed was 1, x squared was minus 6, x was 5, the constant term was 12. Right? In long division, you would write x plus 1. I don't write x plus 1. I write the root minus 1. It's always the first number is 0 and you always add. What is 1 plus 0? 1. Understood? Then multiply 1 times minus 1. I get a minus 1. So you multiply this with that, write it there. Add minus 6 and minus 1, minus 7. Multiply minus 7 and minus 1. I get what? Plus 7. Add 7 plus 5, 12. Multiply 12 and minus 1. I get minus 12. You add, you get 0. You must get 0. If you don't get a 0, either you've gone wrong in this method or your root was wrong. That proves it's a root. That's a remainder. So therefore, look, I started with a cubic. I divided with a power x. So I'm left with the x squared minus 7x plus 12 times x plus 1. This is x minus 3 times x minus 4 times x plus 1. Don't you realize? Much easier to do this division than go through the long division. This is called synthetic division. It's acceptable in the examination, but be careful. You don't use it if you have a factor like 2x minus 3. Because when you factorize and write it, you'll get the answer, but the quotient will be wrong because your coefficient 2x minus 3, you're using the root x equal to 3 over 2. You're not dividing by, in fact, you're dividing by x minus 3 over 2 or x plus 3 over 2 instead of by 2x minus 3. So your coefficients will be wrong. So unfortunately, even though it's a quick method, you can only use it if the root you have is a positive or a negative whole number. If it is not a whole number, please do not use this method because you might go wrong or your factors might be wrong. As long as it is 0, it doesn't matter. If it is not 0, your factors would be wrong. So be careful. Of course, in the handout, I've given a couple of examples, but I want to show you another way of doing this. I don't know, I might have to, let me do this question first. So, x plus 1 is a factor, right? I know, so I taught you synthetic division. Now I'm trying to teach you I'm not giving you notes for this because I wouldn't recommend this unless you're very good in thinking in algebra. So if you are not confident, do long division. If you are slightly confident, do synthetic division. And if you are very confident about your ability, go ahead, don't do any division, use this method. I wouldn't recommend this. I wouldn't do it in the exam because I was never confident when I was a student. Now I am a bit confident. Yeah. So I'll just show you the other method also. I need to factorize. I know x plus 1 is a factor. That means I should be able to get x plus 1. What is the first term here? X cube. To get x cube from x plus 1, what should I multiply by? X squared, right? So what is x squared times x? X cube plus x squared times 1, x squared. Compare this with that. that x cube is there, that x cube is there. But I have written an x squared. Can you see that? Whereas the original question had 6x squared. So how will you adjust? You have added an extra x squared, so you need to get rid of that x squared. So what I'll do will be, can I write it as minus 7x squared? Yeah. So now I have taken care of that. To get minus 7x squared from x plus 1, I must multiply minus 7x times x plus 1 gives me minus 7x squared minus 7x, right? So I'll put a minus 7x. Yeah. Now, but going back, the original question had plus 5x. Can you see that? I have put minus 7x. That means I have to adjust the term. So therefore, to get that plus 5x from minus 7x, I should have plus 12x. Look, plus 12 minus 7 gives me plus 5. Minus 7 plus 1 gives me minus 6 and 12. Now look at this. Between these two, I can remove x squared common factor. Between these two, I can remove 7x common factor. Between these two, I can remove 12 common factor. So look, there is an x plus 1, there is an x plus 1, there is an x plus 1. So if I remove x plus 1 out, I'm left with x squared minus 7x plus 12, which is x plus 1 times x minus 4 times x minus 3. There you are. So, no synthetic division, no long division, but it's a question of adjusting the terms. You need it, because if you go wrong in this step, the whole answer will be wrong. You will never get x, or you might get x plus 1, somehow common factor, but the quadratic here would be wrong. So be careful. This is another, you can practice writing your own questions, but my advice would be preferably do the normal way of dividing. But if you practice a bit more, as long as the root is a positive or a negative whole number, you can use synthetic division, and this can be used for anything else. 2x plus 3, 2x minus 1 factor, it doesn't matter. Suppose you got x equal to half of the root, or if you have, let's say, 3x cube and something, you should be able to do it as well. Okay. I haven't given any examples in the handout for this. Let me see if I can add an example that doesn't work by synthetic. Not exactly doesn't work. End up getting wrong answer by synthetic. I'll put an example there for you to follow. Right? So I've just taken some time to show you different ways of approaching long division and solving an equation greater than, which has a power greater than 2. Alright? Thank you very much. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.